Today we want to finish up our study of the muscular system, and one of the things we want to talk about first of all is the concept of muscle fatigue. Um, After you have exercised your skeletal muscles strenuously for a few minutes, your respiratory and circulatory systems can't supply enough energy to the muscles, and oxygen is necessary for aerobic cellular respiration, which we learned earlier this year, and which is the main way that your body produces large amounts of ATP. But in the absence of sufficient oxygen, the cells will begin to break glucose down into pyruvic acid, if you remember that term. But the process of doing that only releases small amounts of energy to make ATP. And that pyruvic acid, as we also learned, is going to be converted into lactic acid. And eventually, if exercise continues, the demand will eventually exceed the supply. And the decrease of both ATP and oxygen is going to result in the buildup of lactic acid inside your muscles. So if you've ever exercised and your muscles start aching, and actually, you can't push yourself any farther, that's the buildup of lactic acid inside your muscle fibers. And since lactic acid can't be used by the body for anything, it must be transported to the blood or by the blood to the liver cells, where they're going to be converted into glucose. But to do that, they have to expend some ATP energy. So yeah, it was kind of like a short-term solution, but it has to be paid back. And the excess lactic acid in the muscle cells is what it does is it decreases the pH. In other words, it makes it more acid inside of the muscle cells. And what happens as a result, your muscle fibers will begin to not respond when your brain says to move. They no longer can move. So excess lactic acid is going to cause that. Now, this inability of muscle fibers to contract after prolonged use is what we call muscle fatigue. And as you can see in this picture, these athletes have clearly reached muscle fatigue. As your track coach may have asked you to leave it all out on the track, I would say these two athletes clearly have done that. So once you get to this situation where you have this excess lactic acid in the muscles, this lack of oxygen causes the accumulation of lactic acid in the muscles and the liver, and we refer to that as oxygen debt. So it's the lack of oxygen that causes the accumulation of lactic acids in the muscle. So we have an oxygen debt. So if you look at this graph right here, at the bottom left, we have a person at rest, and they begin exercising, and you can see that the amount of oxygen they're taking is not as much as they need to keep going, and so they are creating an oxygen deficit. And finally, you just can't run any faster because you have this oxygen debt. Then when you stop working out or running or whatever sport that you're doing, you have to pay back that oxygen debt, and that's that recovery period that you see there toward the right where it says recovery. You have to rest long enough to pay back the oxygen debt that you accumulated while exercising. And a person that's in poor physical condition is going to build up an oxygen debt much sooner and with much less physical activity than a person that's in good physical condition. So a person in poor physical condition is not going to be able to run a marathon. Maybe once around the track might be more than they could expect to do, whereas a person who is in excellent physical condition can run for 26 miles and not get so deep in oxygen deficit that they can't run any farther. Now, one of the results of this lactic acid buildup is you can have these short involuntary muscle contractions. I don't know if you've ever uh, felt them. Your muscles start to kind of like quiver. That would be a muscle spasm. You can also have cramps from the buildup of lactic acid. They're very painful, and your muscle just contracts and then won't let go, and it usually contracts long enough until even after it does relax, you're going to still feel pain, but it's very painful at the time you have the cramp. So how do we build up our muscles? Well, we have weight training. We have one of those classes at our school where we do that. And the point of weight training is to increase the size of the muscle fibers, not the number. You don't get any more muscle fibers. What you're doing is you're trying to increase the size of each muscle fiber. And you're also going to increase the number of mitochondria and the actin and myosin filaments that are inside of a muscle fiber. So that's what weight training will do to you. And you could tell that when somebody's been working out, their muscles become bigger because the muscle fibers have increased in size. Now, an important part of building muscles and strength is going to be cardiovascular training. That's where we want our heart to pump rapidly to circulate the blood, and that will benefit the heart because it'll make the heart stronger, and the lungs. It usually helps you to increase your lung capacity so that with each breath that you take, you're taking in more oxygen. And the increased number of blood cells leading into the muscles. Remember, the blood cells, the red blood cells, are the ones for carrying oxygen. So when you exercise and your body experiences these oxygen deficits, your body responds by building more red blood cells, increasing the number of red blood cells, so that your blood is carrying a larger amount of oxygen as you exercise. So that's an important part of building your muscles. And so more red blood cells, more oxygen is going to be transported to your muscles, and you're going to be able to exercise longer before you start building up an oxygen debt. Now, what can happen to a muscle is there can be a reduction in muscle fiber size due to lack of use. It looks like possibly this person in the picture looks like they had surgery. I see a scar below the knee, and probably were not allowed to use that leg for an extended period of time. And your body, being as efficient as it is, it starts decreasing the mass of the muscle fiber because it's no longer being used, and your leg will be much smaller, or that limb or whatever it is will be much smaller because due to lack of use. Now, that isn't permanent. If you go through physical therapy and you start exercising it, that muscle can build back up to be as large as it was originally. Now, when it comes to muscle attachments, your skeletal muscles are the ones that are going to produce movement, and the movement, and this was in turn going to exert a force on muscles. And then when the muscles contract, one bone is going to be drawn toward another, like when you bend your arm toward your body, that the two bones, your upper arm and lower arm, are being moved toward each other. And usually there's one bone that remains more or less stationary. Like in that situation, your upper arm is mostly stationary, and then your lower arm is the one that's doing most of the moving. Now, the attachment of muscle tendons to the more stationary bone is called the origin of the muscle. So every muscle has a tendon at either end, and the one that is attached to the bone that doesn't move is called the origin. So every muscle has an origin, and then every muscle also has an insertion, and that's the attachment of the other tendon to the more movable bone. So the one that's moving is connected to the insertion end of your muscle. The end of your muscle that's not moving, that bone, is the origin. So every muscle has an origin and an insertion. Now, the insertion is not always a muscle. Sometimes it can be to another muscle usually at the tendon. So here are some examples of that. At the left here we have the bicep at the front of your arm, and its origin is attached to your scapula. That's your backbone. I mean your shoulder blade, and the tendon is attached to the radius, the bone in your lower arm, and when your muscle contracts, the origin and insertion move toward each other. Now, there is another muscle that is at work that extends your arm. It's attached also to the scapula or your shoulder blade, but kind of on the opposite side of your humerus, your upper arm. And it's attached to the other bone in your elbow, and when it contracts, it causes your arm to extend. The muscle that makes up your calf muscle is called the gastrocnemius, and the origin of that is located on the bottom of your femur, on the back side of your femur, and then that muscle has a very long tendon that goes down to your heel bone, which is your calcaneus. And so when this muscle contracts, then it's going to pull the heel bone closer to your knee, causing your foot to point. So let's talk a little bit about muscle actions and some words that they use for that. One word that they have is like extension and flexion. You have one muscle that's going to cause a limb to extend itself, and then there's going to be one that causes it to bend, to flex. Your hamstring muscles in your leg kind of do that. You have one that brings it closer to your body and away from your body. So, and we also have another pair working together that we call abduction and adduction. Notice there's only one letter difference between those. The ab in front of duction means away. So it means moving away from usually like the center line. Like if you were standing up straight and you move one leg off to the side, that would be abduction. When you bring it back toward the middle, that's going to be adduction. So when you swing it out, that's abduction muscle responsible for that. That will be on the outside of your leg, going up to your hip. And the adduction is going to be a muscle on the inside of your leg that will go toward the center line of your body. Okay, your deltoids and your pectoralis major. Your deltoid is the muscle on the top of your arm that kind of makes a cap over the end of your upper arm. That's your deltoid muscle, and that muscle is the one that you use to raise your arm out to the side, up and out to the side. The pectoralis major, that's the muscle that makes up your upper chest bone, upper chest, and it's the one that brings your arm toward the middle of your body. Then we have some muscles that are responsible for rotating your head. Your sternocleidomastoid, as you can see in this diagram, where it's attached to your head and then it comes to your collarbone, and it's the one that allows you to rotate your head from side to side. And then you have some bones that are responsible for elevating, raising something up, or depressing, lowering it. And you have some muscles that, when it comes to chewing, that serve that kind of purpose, lowering the jaw or raising the jaw as you chew. Now, muscles always pull, but they never push. And they almost always work in pairs, or in groups, I should say. There's not just one muscle doing it. There's usually a group of muscles that accomplishes a larger action. The prime mover is the one that performs the main action. So in a muscle group, there's some muscles that are called prime mover, and they do perform the major action. But then there's some that we call antagonists. They perform the opposite action. They move. So these two kind of like work against each other. We often refer to those as antagonistic pairs. So using our upper arm again, the bicep and the tricep are an antagonistic pair. They fight against each other. If you try to contract both of them, your arm neither moves closer to your body or extends. What you might see somebody flexing their muscles, they're trying to make both antagonistic pairs contract at the same time. So no motion happens. Now, synergists are going to be ones that work together. So you might have several muscle groups that are both helping to, let's say, move your arm across the front of your body. You actually have a couple groups of muscles that work to do that. Now let's talk a little bit some problems that you can experience if you experience a soreness on the front of your leg due to straining a muscle. It can also happen in the back part of yours. This is quite often experienced by runners when they run on hard surfaces like pavement, and thus a lot of tracks. I know the track that we walk on is a rubberized track, and you can actually feel it squishy under your body, and that is less likely to cause shin splints. And it's just an irritation or a soreness in the front of your leg. That's where most people have it, and you just need a. Let's take a look at some muscle disorders that uh, people may have. One is called myalgia. There's fibromyalgia that you may have heard. You may have known some people that have that. This is just a muscle pain. Uh, it can be quite painful and incapacitating for them that results from some muscular disorder or disease. Uh, Another one is convulsions. These are violent involuntary contractions of an entire muscle group. It will cause them to shake the whole body. Uh, and this is uh, pretty characteristic of somebody who maybe has epilepsy and they experience these epileptic seizures. And often they're on medication to minimize these or make them happen very seldom or very mildly. And then there are people who are coming down off of a drug withdrawal that can also experience these convulsions from withdrawing from a drug. And then we have paralysis. This is the inability of a muscle to move. In other words, you're trying to consciously move the muscle and there is no motion there. And it's usually because some part of the nervous system has failed. And that could be a nerve going to the muscle that's to stimulate the muscle has been severed or damaged in some way, or it could be even caused by a part of the brain that controls that motion has died due to a stroke. Those are some different things that can cause paralysis. Now, the last thing we want to talk about here is the human anatomy and physiology. We're talking about muscles, and here's some muscles that I would like you to know the names of and where they're at and kind of what they do. The trapezius, we'll start over on the left. The trapezius is the muscles that go from your neck to your shoulder. They kind of fan out on the back side of your back below your neck, or kind of like on the side of your neck. That's the trapezius. We've already talked about the deltoid. That's like the cap over the upper end of your bone. The muscle that makes up your chest is the pectoralis major. Athletes sometimes refer to them as their pecs. And then the bicep is the muscle on the front of your arm. The biceps brachii are the ones that cause your arm to bend, like if you're doing arm curls. Then we have the muscles that make up the front of your leg, and they're the quadriceps. Sometimes athletes just refer to them as the quads, but the full name is the quadriceps femoris. The femoris means it's by the femur. Remember, that's the upper leg bone. And then we've already talked about the muscle that makes up your calf, and that's the gastrocnemius. And then going over to the right, we'll start on the left side of the right picture. We have the triceps brachii. Those are the muscles on the back part of your arm that cause, when they flex, it causes your arm to go straight. And then on the back part of on your back, under your arm and down towards your hips, you have the latissimus dorsi. Athletes will often refer to them as their lats. They're just taking the first three letters. Then the part that makes up your bottom, the part you sit on, is your gluteus maximus. And again, athletes, they like to shorten everything. They just talk about their glutes. And then the muscle that's on the backside, in other words, it's on the opposite side of the quadriceps femoris, you have the hamstrings. And then I think that pretty well takes care of it. So those are the muscles that I would like you to learn where they're located and their names. And that takes us to the end of the chapter.